I will now show how we can solve the second assignment for the course, which is the math interpreter. And I'm going to be working with most parts of the assignment at the same time and showing you how to do a fairly minimal but proper solution. We're going to be dealing with a number of things at the same time, although I'll try not to make it too much. But something which is nice to do when we're doing mathematical expressions is use the returns specification. So this means that everything that we do here is going to be an expression. So this makes it much easier. So whether it's plus or minus or a number or whatever, binary operations or single things, they're all expressions. So this gives us a nice class hierarchy that is easier to work with afterwards. Now we're also going to say that an expression, so that's something we add or subtract, may be just a factor. And in this case, we don't need a left, because if it's just a factor, then it's just whatever it was. But if there's more, then we need to introduce the left. And we're going to do that saying either it might be it's a plus, then we would say that it was a plus with the left equal to current. If it's a minus, then it's a minus with the left equal to current. So this is replace whatever we have with either a plus node or a minus node, and then the thing that's the factor is then the left or the right. And then we say, well, right here is going to be a factor, and we want any number of them. So here we're saying an expression is made out of factors that are combined with plus or minus, and the objects that we build here are either plus objects or minus object. And the plus object has a left and the minus object has a left, and they both have a right, and they're all in fact going to be expressions, because an expression is also a factor is also going to be an expression. And here we need precisely the same thing again, or almost. So this is then a primitive, and this might be a multiplication, and then it would be a mult.left, or it might be a division, and then it's a div.left. Note how we are no longer right recursive here. In fact, we're not recursive at all. So the grammar doesn't make what we're doing left associative or right associative, but the way we build the tree here makes us left associative, because it's the left side we put whatever it is we're building into. A primitive is then, well, we almost have it, our primary. Let's make it primary here, because we have that down here. So primary, okay. Primary might be a number or a parenthesis. A primary also is an expression. And the parenthesis, now we can cleverly just do it like this. Returns expression, like so. So if there's something with a parenthesis, it's just another expression. So we don't need to treat the parenthesis differently. If we have a number inside a parenthesis, it's just a number. It means that we forget about the parenthesis. We don't know about it anymore, but it gives us the right structure. So this is the basic grammar. We have the right kind of precedence. So multiplication is stronger than addition, for example. We don't have right recursion anymore, so it's not right associative, and the way we build the tree makes it left associative. We have parentheses. So this is actually most of what we need for what I asked for at the sort of for a 3. If we also want the binding, then we can say, oh, there might also be a variable binding. A variable binding is let some variable, be equal to the what should we call this? Binding equals, that's an expression in body is equal to expression. And we can put an end here just to be nice. So let variable equals id in equals let x equals 5 times 2 in x or whatever. Then we need to say that we should also be able to use a variable. So and this is a variable use. That's an ID. Okay. So now we can write our expressions and we can bind variables. At least we have the syntax for that. So let's do a run as generate xtext artifacts. Anything? No. We pause while I figure out what I did wrong. And looking at it very briefly, I think this is where the problem was. We don't want to say that the factor is built up of a whole bunch of factors. In fact, just like up here, we're not doing recursion at all. We're just saying there's a whole bunch of primaries. I'm crossing my finger that this is the right one. Sorry about that. And it works. Okay. So now we can go to work on the generator. Okay, and now we want to say that our expression here, we import that. Okay, so for the math, we do a compute exp, and for our compute exp, well, our expression might be a whole bunch of different types. So compute exp, we could write that as a dispatcher. In this case, we might actually also want to I'm just now noticing that I maybe left a trace of some bad code for some of you. Sorry about that. I had cases here. I think that confused some of you. So if it's a plus, then we do left exp dot left dot compute exp like this. So if it's plus, we plus them together. Just going to put this line in every place here. And a few things I now realize I forgot in my grammar. So this lets us write something like this very conveniently. Default throw. We shouldn't be at the error. Invalid expression. Okay. So this is significantly simpler than what we were able to do before because we have a nice grammar. The grammar is missing something that I might be missing something. I just want to check. So the variable use should also be an expression. The variable binding should be an expression, and the number should be an expression. And let's have this be an object called num. This should be an object called let, and this should be an object called var. This, and I just need to regenerate because I've changed my grammar. Okay, so now I go back to my I can say if it's a number, then x dot, and this as a value. Okay. And then I have var and let. I haven't really figured out how to do those yet. So what we want there is basically a way to bind. We want a mapping from variable names to values. So an easy way to do this is to use a map, and then be careful never to override anything in that map, because if we put bindings inside bindings, we should still remember the old one when we're done with it. And we do that by making there are many ways of doing this. One easy way to do this when we are in extend here is to use maps and then create maps from existing maps. So let me show you. So here now we need to start with an initial empty map. So this is a new hash map and this is from string to integer. Import hash map, and here we say, oh, and we take a map from string to integer as our environment. Okay, and the environment is just passed as an argument to whenever we call the computex like this. If we have a variable, we expect that the variable name is already bound in our environment. So that's going to be n dot get of, and the expression is then I think it's var name. No. Var. Okay, x dot var. That's var is a bad. That's a keyword. Here. No, it's just called ID. Okay, and ID. So the problem is that var is a keyword in extend, and this I could write get var actually, and that would have worked, but just to keep the thing nice, we're not going to do that. We're going to be consistent. And no. That's funny. So var has an ID and let has an ID. As a get ID. Okay, sometimes extend is a little annoying. Okay, so it's actually fine. Okay, and now we have the let. And for let we not need to do a x dot body. I think it was dot compute expression, and we need to we need to give it a new environment. I'm just going to use a helper method for that. So I'm going to call bind. So I'm going to say n.bind, and it's x.id to x.binding.compute_exp. Okay, so we bind the name of the variable to whatever expression we want to bind it to, which we need to compute using the current environment. And we use this to make a new environment that we use to compute the value of the body. And let's create this extension method here, bind. Okay, int. So this is our environment. This is the name. This is the value. And then we're going, so what we're going to do is simply we're going to create a new map. This is environment 1, environment 2 equals new hash map string integer, and this means copying all the bindings that are in the original one. So we got a copy of everything we knew before, put it here, and in this new one with a copy, we're going to put name value, and then last we return the environment. Okay, so I think that's it for the how to compute something and how using the binding here. We still need the display function, and the display function is actually a lot like this. So I'm just going to code, then we're going to say this is display math.x.display exp, and we don't need an environment to display something. And this is display exp. Okay, and then if okay, so plus let's just, this is actually, this is no longer, so this is a string, okay. This is display exp and display exp, like so. Okay, this is the line we want. Just going to put it everywhere. Minus, multiply, divide. Number, that's integer.toString. The value, the identifier is just going to be the identifier itself. For a let, we want to say, here I think it makes sense to use a template actually. So let me get rid of this here. Let's, and this is the x.id equals, and then x.binding dot display exp in exp.body dot display exp, and like so. Okay. Right now, we've thrown away the parentheses when we passed it, and we don't have the parentheses here. going to fix this. This is an old import. Sorry. So right now the output will actually be ambiguous, and it's nice to be able to see the outputs. So I'm just going to say that, oh, we actually want parentheses around everything that our display. So we're going to get lots of parentheses. Okay, I think that's it. So now it's exciting. Let's try this. Of course, I actually haven't really tried this before, so there's a significant risk that there's an error somewhere that some of you may have spotted. Let's try this. Okay. Okay, that's fine. So result is 86 plus 1. Ah, it works. Maybe. Let's try. 88. Okay. 86 plus 2 times 5. Oh, let's say 40 times 2 plus 7. This seems to be right. And let's go look at the output here. 40 times 2, and that has parentheses around it. 7. Okay. And let's do 40 plus 2 times 7. 54. And go look at it here. Okay. That's the operator precedence. Right. And seems to be nice. If it's 40 minus 2 minus 7. Okay, that's good as well. And we can do parentheses. 45. Okay, and okay, now let's try some bindings. Let x equals 2 times 3 in x minus 1 end. Okay, so that's 6 and x minus 1. Okay, in let x equals 8 in okay, so now the inner one here should be 7, and let's multiply that. This should then be 35. No, 42. Ah, okay. Sorry. X equals 8. That's 7. Ah, this is 6. Okay. 7 times 6, that's 42. This is all beautiful. Okay. So it seems to work. We're happy. And this is what it looks like. And that's it.